didn't all get perfect papers. In fact, there weren't very many perfect papers. Emma?
One on D.
Quiz D number 1. All these are done the same way. Thank you. Here, Maya. All right, so this is an absolute value problem. So everybody had one of these. Yours might look a little different, but it doesn't make any difference. They're all done exactly the same way. So right here in the middle of the number line, I'm going to put the opposite of this number. This number is in the middle of the problem. It goes in the middle of the number line. This number right here, so opposite of it. So I'm going to put a 2 there. Now I'm going to go forward or add that many, so I'll be out 5. And then I'm going to back up that many, so I'll be at -1. Okay? And then I'm going to shade those in because that's an or equal to. And then a common theme we have, guys, is when it's greater than, we shade where? Out. If there's only 2 dots, when it's greater than, it is shaded out. So we have x is less than or equal to -1, or x is greater than or equal to 5. Please don't try to write that as one answer. You can't. It is 2 distinct answers. So therefore, it must be written as 2 distinct answers. Okay? Anything else? Another problem from the quiz? Caitlin?
Quiz A number 1.
Quiz A number 1. Quiz A number 1 is our quadratic inequality. All right? Our quadratic inequality. Now, how do we do this problem? Folks, I saw all kinds of weirdness on these papers. Don't make it hard. What do? We factor it. We factor it, that's all. So this one factors as x plus 2 and 6. So then we draw our number line. Anytime we have an inequality, we're going to draw a number line and do some shading. So on the number line, I'm going to put 2 dots. And they will be at the opposite of these numbers. And I got to make sure I get those in the right order. A couple of you got those turned around. Make sure you remember somewhere here is 0. And then you'd have -1, -2, -3, -4, -5, -6. So we got to go in that order. Now this is another greater than problem. So what did we just say with greater than problems? Shade it out. So our answer again is less than -6 or greater than -2. And those are open dots this time because the symbol doesn't have the or equal to. Johnny?
What is less than? On your write the full answer.
If we have a less than problem, so we shaded in between the 2 numbers, then we put x right in between the 2 numbers and use less than symbols every time. All right? Okay. We can't, those are guaranteed test questions. You know those are going to be on the test, so we got to make sure we have that under control. All right, well, speaking of tests, let's get out practice test number 2. And this one is exactly like the test. I mean, the size of the paper, everything is exactly the same. So when you get your test on Wednesday, it's going to look just like this, practice test 2. All right, ready? Here we go. Which property? What are you doing now?
I forgot to staple the extra ones.
Which property is shown? No. What property is A? Additive inverse. Guys, when things cancel each other out, it's an inverse property. Okay? If you get 0, it's the inverse. If you add 0, it's the identity. Alright, what about letter B? That is associative. Did the order change?
No.
Nope. So that is associative. We regrouped. What about C? If things cancel out, it's an inverse. What's happening in C? They're canceling, so it's the multiplicative inverse. The multiplicative inverse. Mult-inv. M-U-L-T-I-N-V. Multiplicative inverse. If things cancel out, it's an inverse.
For like A, should we write additive inverse?
Yes. All right, number 2, here we go. Solve this now. Does this have a less than or a greater than in it? No. So we're not doing the number line thing. Your job is simply to tell me what x equals. What kind of an equation is this? It's a quadratic. So you have to solve a quadratic equation. What do you want to do? You could use the quadratic formula, right? Now, if you want to mess around trying to factor it, it might factor. Factoring might work. But you know the quadratic formula will work. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we want to be really careful in here. Sometimes we just mess this up because we try to go too fast. It's a double negative, right?
Yes.
That means it's going to be an add. So what is this? 2, 12, 48. So 1 plus 48. Which is 49. Which is wonderful because that is 7. So now I have to actually work that out. So I get 1 plus 7 over 12, which reduces to 2/3.
Yep.
And 1 minus 7 over 12, which is negative 1/2.
Yep.
Since I got nice, neat little answers like that, I know I could have factored it if I would have tried to. This one would factor, but they don't all. But this one does. Any question about that? All right. B. Oh, we just talked about this one. This one is an inequality, so I know I'm going to draw a number line and do some shading. It has a greater than. What?
Number 7.
Oh, the number 7. Oh, thank you. Okay. So now in the middle of the number line, I'm going to put a -2. Remember? The number in the middle of the problem, put the opposite in the middle of your number line. So that's going to be -2. Now I'm going to take that number and I'm going to go both ways, that number. So if I add 7, I'll be at 5. If I subtract 7, I'll be at -9. They are open dots. It's a greater than, so it is shaded out. Two-part answer. X is less than -9 or X is greater than 5. Every single one of those is done exactly the same way, right?
Yep.
So we ought to be getting the hang of that. Okay, C. Not an inequality, so don't draw a number line. All we have to do here is solve but it's full of fractions. So what do you think? What? Multiply by 12. She says I'm going to multiply everything by 12. Now, is 12 the only number she could multiply by?
No.
No, but it's the smallest one. Some of you might have thought, oh, I'm going to multiply by 24. That would be fine. That would be absolutely fine. The whole point is to multiply by something that will make these denominators cancel. The reason you're doing this is to make the denominators cancel, so cancel them. So 4 goes into 12 3 times, leaving me with 6x minus 3. 6 goes into 12 twice, leaving me with 2x minus 4. And don't forget, even though there's no fraction over there, you still have to multiply it by 12. Once you start multiplying by 12, you have to multiply everything by 12. 8x minus 7 equals 24. 8x equals 31, and x equals 31/8. What is that? Is that okay with everybody?
Yep.
All right, that page is easy. Everyone will get a perfect first page. All right, now number 3a, I have another inequality. So that means when I see that inequality symbol right there, that less than or equal to, I'm going to draw myself a number line. Obviously, I'm going to put some dots on the number line. How am I going to get the dots? Factor. I'm going to factor. So this one factors as minus 4 minus 1. So where will the 2 dots on the number line be? At 1 and 4 in order. And they'll be colored in this time, right?
Yep.
It's a less than problem. So this is our first less than of the day. That means it's going to be shaded in between.
Yep.
A 1-part number line answer means I'm going to have a 1-part answer. So I'll just pop the x in between the 1 and the 4 using less than symbols. Or a lot of you are using your interval notation, which is awesome and easier. Okay? All right, B. This looks very simple. What shall we do? Square both sides. I got 27.
Yep.
Now this is the kind of problem that you might get extraneous roots for. The process of squaring both sides introduces extraneous roots. So I'm going to check it. 27 minus 2 equals 5. Is that true? Yep. So we're good. 27 is our answer. Now, folks, I'm the teacher, but I'm thinking this is pretty easy, right? We shouldn't be sweating this. We got to be rolling through this. Now, this next one's a little bit trickier. This has way too many terms. Now, it's an equals, so no number line, it's an equals, but it's got too many terms. What am I going to do? Do you remember we did one of these on Friday? Miss Piper? What?
Put it into 2 parts.
Yep, we're going to break it up into 2 parts. So maybe we'll just look at the first 2 terms as 1 part and the last 2 terms as another part. If we look at the first 2 terms, just this box right here, what can we do with those 2? Take out what? X squared. And that will leave us with, we're taking out an x squared, so that will leave us with x plus 3. Alright, now let's look at this box. What can I take out of that? A negative 4. Now you took out a negative 4, so that's going to leave you with an x plus 3 again.
Yep.
And that's the key. We have to have a match. So we do, so I'll write down the match. And then everything else that's not the match, which is x squared minus 4, goes in a separate parentheses. What about that? That's the difference of squares, so it's x plus 2 minus 2. Yep, in either order, doesn't matter. No number line, just write the answers. What does x equal? Negative 3, negative 2, and 2. Is that what you said? Order doesn't matter, so that's great. Everybody okay with that? All right, number 4, we're going to simplify. Anybody who foils this problem, I don't know what I'm going to do. I'm going to make some kind of mean comment on your paper or something. We do not want to foil this. When do we foil? If we are multiplying. These are not being multiplied. They are being subtracted. So, yep, we take out the parentheses and distribute. So 4 minus 2i minus 6 minus I. Collecting like terms, negative 2 minus 3i. What about this guy? This is going to be a little bit more labor intensive here. Do not cancel. Oh my goodness gracious. There is no canceling that can happen. I'm going to multiply top and bottom by 2 plus 3i, which is the conjugate of the bottom here. Now I'll FOIL, right?
Yep.
On the top and the bottom, I'm going to FOIL. So, first, outside, inside, last. First, outside, inside, last. You kind of got to be careful. It's easy to make arithmetic mistakes. I think I'm okay. All right, now tell me about that. We can combine like terms, and remember that I squared is negative 1. So when I have a 9i squared, that's really a negative 9. Which added to the 8 is going to make negative 1 plus 18i on the top.
Yep.
The bottom has a negative 9i squared, so that's actually going to become a plus 9.
Yep.
These are going to cancel, so I just got 13 on the bottom.
Yes.
And remember, these are the ones, even if this had been, let's say we had 2 plus 13i over 4. Even if we had that, we wouldn't cancel the 2 and the 4. Don't cancel unless you can cancel out of all 3 places. So if we had 2 plus 18i over 4, then we could cancel out of 2. But don't cancel unless it's all 3 spots. So that's the answer right there.
Oh, okay.
That's it.
I got two. I got that.
All right. Now, simplify. This is our exponent problem. Okay, now forget the exponents or the variables for a minute. Forget the variables. You have a 4 over 12. Let's not make that complicated. 4 divided by 12 would be 1/3. Now I'll look at my x's. I have 5 of them over 10 of them. When I start canceling, it's going to leave me with 5 on the bottom. Now I've got a negative y, so he's going to have to go to the top, right? When they're negative exponent, you move them. So I'm going to take these 3 to the top. There's already 8 up there, though, so that's going to leave me with y to the 11th. You don't actually have to have that 1 written in there. You can if you want, doesn't matter, but it doesn't have to be there. Write the equation of the circle. Remember, circles look like this. In the first parentheses go the x's. So that's going to be x
Plus 2.
minus 2. Whenever we put things in parentheses, it's always the opposite. Just like it is with the absolute values and everything else. So x minus 2, y plus 1, and over here goes r squared, so that's going to be 25. So there's really no work to do on that problem. You just have to memorize what the equation of a circle looks like. That's what it looks like. All right, write the equation of the line. Okay, so what pops into your head when we say write the equation of a line? Gotta find the slope. So our points are 2, 4, and 1, 6. Eva, did you come late or have you been here all period?
I've been here.
Okay. All right, so what's my slope? 6 minus 4 over 1 minus 2. We are going to get that right. We are seniors in high school. Y minus y over x minus x. 2 over negative 1. I heard somebody say negative 2 and that person was right. That is not the answer though, because the answer is, or the question is, write the equation of the line. So what do you want to do? It's up to you. What? Pick one of the points. I'll pick this one. I don't care, it doesn't matter. I'll just pick that one.
Y equals x plus b.
And one strategy is y equals mx plus b. I know this is my x and my y. So 4 equals negative 2 times 2 plus b. So b equals 8. Which means y equals negative 2x plus 8 is my answer. Now, some of you don't do the problem this way. Some of you use point slope, which is absolutely fine. You don't need to do it both ways. I'm going to do it both ways this one time. You don't need to do it both ways. Just pick a way and do it. Same point. So y minus 4 equals negative 2. X minus 2, and lo and behold, we get exactly the same answer, of course. Everybody good? All right, next one. Now we're going to write the equation in the line parallel to a given line, so parallel to this one, and containing the point 2, -3. Okay, so what's your thought on that? We're writing the equation of a line, so essentially we're doing the same thing, but it's got to be parallel to this and contain that point. What? Get y by itself, because if you get y by itself, then you'll know what the slope is, right? And parallel means same slope. So I'll get y by itself. I got a slope of 2. Now, since it's parallel, I'm going to use 2. What if it had been perpendicular? Opposite reciprocal, so I would have used -1/2. But it's a parallel, so I'm going to use the same slope. So I'm going to use that slope and that point that they gave me. So if I do y equals mx plus b, and it doesn't matter, you can do it either way. -3 equals 2 times 2 plus b. I got -7. So my answer is 2x minus 7. Y equals 2x minus 7. We are almost done already. You sleepy people still with me?
Nope.
All right, so now we've got our projectile motion problem. The ball is thrown into the air. Here's the formula, which I promised I'd give you. A, write the equation for this problem. So it's going to be -16t squared. All right, now we got to plug in an initial velocity and an initial height. So it says the ball is thrown from the top of a 20 feet tall building. The initial velocity is 80 feet per second. All right, so just plug in. So we're going to have -16t squared plus 80t. Don't forget that t. Sometimes we forget there's a t there. 80t plus 20. Perfect. That's A. That is the answer to A. Now remember, if it's easier for you, you can rethink that as y equals -16x squared plus 80x plus 20. There's nothing wrong with that. Thinking about that, because we are going to be eventually going to our calculator.
If we write that as the answer, will we get points taken off?
If you write it as the answer to A, you will, because it says A, the answer blank is set up with S of t. Okay, but as you do the problem, we're ready to go here. So, how high is the ball after 1 second? Okay, we're going to plug in 1 for either y or x. Where does the 1 go? X. Because x is the time variable, right? So y equals -16 times 1 squared plus 80 times 1 plus 20. We don't graph that. We just type it in. We just plug in 1 and go. So that would be 84 feet. So how high is the ball after 1 second? 84 feet. Remember, once you've written your equation, every question simply requires you to plug in either a y or an x. So you're either going to plug in a time or a height. Alright, here we go. When is the ball on the ground? So we're using our same equation. When is the ball on the ground? Plug in 0 for y. So we have this equation. And I hear the calculators coming out. Because the scenario is this, the ball is on top of this building, we're going to throw it. We want to know when it hits the ground, which means we want to find the x-intercept or the 0. So we'll clear out the old and put in the new. I have no idea how your window is set. So I might just go Zoom 6. Now again, we are looking for this point, right? When I zoom 6, I see that point. I don't see this nice shape because this part's missing. But I see that point. That's what I need. So I'm going to find it with my second Calc 0 menu. And I think my answer is about 5.2386 seconds. So I don't know, does it tell me how to round that off? No. So when is the ball on the ground? At about 5.2 seconds. Anybody else get that, by the way? Okay. When you look on your screen, my screen says x equals 5.23, that number, and then over here it says y equals -1e to the -11th. Does anybody else have anything that looks like that? Or have you ever seen anything that looks like that? This is scientific notation times 10 to the -11th. So you can think of that as 0. That is about 0. That's a very, very, very teeny number. So the answer is, when is the ball on the ground? 5.2 seconds. And finally, the last two questions. What is the first one asking me for? What does AB mean? It means the distance, folks. It means the distance. So your points are 4, 1, and 6, 11. So 4 minus 6, 1 minus 11. We subtract our x's and subtract our y's. So we got the square root of 4 minus 6 squared. 1 minus 11 squared. So we have the square root of 104, which, if it breaks down, we break it down. So 104 divides by 4, I think. 4 times 26. So that's 2 and 2, and 2 and 13. So out comes a 2, in stays a 26. There's my answer. Midpoint. I need the midpoint of AB. So there's my A and B. Midpoint means average. So I'm going to add 4 and 6 and divide by 2. 5. I'm going to add 1 and 11 and divide by 2. Test done. Right? Over. Andy! Woohoo! Alright, so, given all that, what kinds of problems do we need to practice? Okay, now, somebody said we need to practice complete the square. I am happy to complete the square. But did I have to do that on any of these test questions?
No.
Remember, the thing we just did is exactly what the test is. So if we did something a minute ago that what are you doing? Okay, you guys that are doing this, these are late. You can't be doing that. You can't be finishing up during class and then turning it in. The test is just like this. So of the problems that we just did, what do we need to practice? What kind of inequality? Absolute value inequalities. Right? Now you can write these on your desk on a piece of scratch paper, wherever, but we should all be practicing, because like I said, there weren't, I don't know if there were any perfect quizzes, maybe 1 or 2, so we've all got something to practice. Alright, so the test is going to have one absolute value inequality on it. So here is an absolute value inequality. We're going to have one of these on the test, just like we had on the practice test. This one I made a little bit harder, because there's a 2 in it. So we'll divide everything by 2. We are perfectly capable of doing that. We practiced that. So we have x plus 3 is greater than 4. Right? So anytime, let's get programmed. Anytime we see an inequality symbol in the problem, let's think number line. Because anytime we see an inequality, we're going to be doing shading, right? Alright, so here we go. In the middle of the number line goes the opposite of the number in the middle of the problem. So the number in the middle of the problem is x plus 3. So I'm going to put -3. And then I'm going to take this number and I'm going to add that amount, which would put me at 1, and subtract that amount, which puts me at -7. Since it's a greater than, we'll leave those dots open and we will shade out. And then we will write our answer. X is less than -7, or x is greater than 1. Yep. So let's throw a ball off the top of a building 17 feet tall. And let's throw it with an initial velocity of 11 feet per second. And so let's do the same 3 problems we do on our test. So we got to write the equation for this problem. When it's on the ground, actually we're going to need an extra one because there's actually 2 different questions that could be asked here. When is it on the ground? When is it 19 feet above the ground? And how high after 2 seconds? here's the given, we're throwing the ball off the top of a building 15 feet or 17 feet tall, and its initial velocity is 11 feet per second, and we want to know how all these things. Okay, for general formula. Given to you. So writing the equation should be a no-brainer. This should be the easiest point on the test. S of t equals negative 16t squared plus 11t plus 17.
Yep.
So that's the answer to the question that says write the equation. That's the same as negative y equals negative 16x squared plus 11x plus 17. So here we go. When is the ball on the ground? When you do these three problems, you're going to take that equation and you're either going to plug a number in for y or you're going to plug a number in for x. If you're plugging it in for y, it's a height. If you're plugging it in for x, it's a time. So, when is the ball on the ground? That means the height is 0. So I'm going to put a 0 in for the y. If it is on the ground, its height is 0. So then, I use my calculator. Type in that equation. And what am I looking for? I'm looking not for both zeros. When I graph this one, I get a picture that looks kind of like this in a standard window. I don't really want that one, do I? Because what would this one represent? A negative time? So that I only want that one. That's the only one I want. So second calc 0. And I got about 1.43. When is it on the ground? About 1.43 seconds. Uh-oh, I got a problem. I'm going to need to, yeah. Because if it's on the ground at 1.43 seconds, it's obviously on the ground at 2 seconds. So I'm going to put a half in there. I'm going to change that last problem to a half. All right, when is it 19 feet high? So think about it. You're standing on top of a building that's 17 feet tall, and you throw this thing up into the air. Is there a time, or maybe 2 times, that it's 19 feet tall? So go back to your equation. Where do you put the 19? In for the y or in for the x? Y. Why do I put it in for y? It's a height. Heights go in for y. Times go in for x, right? So this is going to be 19 equals negative 16x squared plus 11x plus 17. What do I do to go forward with this now? What? Subtract the 19. You got to get it set equal to 0. And then you're going to do exactly what you did with this one. You're going to type that in and you're going to see what the zeros are. Oops. First I have to type in that equation. Remember, for each problem you have to change the equation if you put in different numbers. Uh-oh. remember, I made this problem up. So, anybody notice anything? When I graphed this one, I got a picture that looked like this.
It doesn't.
It doesn't. It doesn't. It doesn't cross the x-axis. There aren't any zeros. There's no solution to this equation, which means what? When is it 19 feet tall? Never gets that tall. Never gets that tall.
When you plug in your zero, it just doesn't, like when you try to plug in your zero, it means zero.
What?
Like, so in order for there to be no solution to this, or if it's
The answer to the question is it never gets that tall. It doesn't get that tall. It doesn't go that high. Remember, I made this up, so. All right, how high is it after half a second? Plug it in for x. So I'm going to plug a half in for my x value in my equation. Go back to the equation again. So y equals negative 16 times a half squared plus 11 times a half plus 17. I'm plugging in a half. So that's 1/4, negative 4 plus 5 1/2. Did you get 18 1/2? So
I got 14.
Wait a minute. Try again. I think I'm right.
Oh, yeah.
Now, originally, I had a 2 here. If you plug 2 in, you get a negative number. Because remember, the ball hit the ground after 1.4 seconds. So after that, it's still laying on the ground. But 1/2 worked out okay. It's 18 1/2 feet tall. Okay? Maddie? You paying attention? Uh-huh. All right, so what else? Yes, Miss Piper?
You know how we have the, kind of parallels, they're gonna be perpendicular ones?
Yeah, write the equation of a line perpendicular. All right, so the question says, write the equation of the line perpendicular to 3x plus y equals 4 and containing the point 5 negative 2. So write the equation of the line. When you see those words, write the equation of the line. The first thing that should pop into your head is, oh my goodness, I need a slope. I need a slope. If you're given 2 points, you know how to find the slope, y minus y over x minus x. But you weren't given 2 points. You were told you're going to be perpendicular. So what's the slope of this line? Y equals negative 3x plus 4. So the slope of this line is negative 3, right? Which means the perpendicular slope will be 1/3, positive 1/3. So now we have our slope and we have our point. So then it's up to you. You're either going to point slope it or slope intercept it, whatever you like to do. I slope intercept last time, I'll point slope this time. So y plus 2 equals 1/3 x minus 5. is my x and my y right here. So y plus 2 equals 1/3 x minus 5/3. When you multiply 1/3 times 5/1, it's 5/3. Now I'm going to subtract 2 from both sides. So y equals 1/3 x. Okay, so I have a negative 5/3 minus a 2/1. So that's a negative 5/3 minus a 6/3. Negative 11/3. So there is the answer to my question. Okay, we got time for one more. What else that was on the practice test you think might trip you up? Emma?
The ones where there's like fractions and exponents.
So, let's see. 10 8 x to the negative 3rd, y to the 5th, y to the negative 8th, z to... Alright, let's try this. Alright, let's see what we got here. So the directions say simplify. Forget all the letters for a minute. What happens with the numbers? 5/4. Now, one letter at a time. This is the only x going down. There are 2 y's. That one is negative. Bring it down. So you're bringing 8 down, but there's already 5 down there. So y to the 13th. And the z just stays down there. Alright, I'll see you people tomorrow. On Wednesday, remember what happens is we will do practice test 3 and then take our test. Now listen, if you are extended time,